Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from second group and now we will present and discuss about plant disease intensity. And in our group there are 5 person member. The first is Cahyo, Budi, Bhakti, Bumi with student number 048, and second is Ismi, Aflahal with student number 051, and next is Yusuf Arifin with student number 054, and next is Refido Arian Tohari with student number 056, and at the last is me, Fatahilah Ahmad A with student number 057. Okay, plant disease can be defined as deviation from normal traits that cause plants to be unable to carry out physiological activities as usual. Plant disease can be caused by biotic and abiotic factors. The intensity of disease attack is the level of attack or the level of damage to plant caused by fungi, bacteria, or viruses, expressed quantitatively and qualitatively.
The use of scoring is measuring the intensity of plant disease. The severity of the disease as well described by dividing the range between disease free to fully affected areas into a number of attack categories or attack classes. The attack class of scoring method is a method that uses class division or scores in assessing the scale of plant damage. Through the calculation of the severity of the disease, we can predict the value of occurrence of the disease. It certainly facilitates the process of preventing and controlling disease in agricultural cultivation. By knowing the intensity of a plant disease, we will be able to determine the economic and environmental impact caused by the disease. In addition, the scoring also underlines farmers in making decisions on the management of the agricultural land, so that farmers know the next action that must be taken.
How to determine the value or score of disease symptoms in plants. If the plant is healthy, there is no symptoms attack, the score is 0. If the plant is mildly attacked, the number of leaves affected and the attack on each leaf was few, and the plants look healthy 1 until 25%, the score is 1. If the plant is moderately affected, the number of leaves affected and the number of attacks on each leaf is rather high 26 until 50%, the score is 2. If the plant is severely affected, number of leaves affected by leaves, the number of attack on each leaf is 51 until 75%, the score is 3. And if the plant is dead, all leaf withered and no sign of life 75%, the score is 4. Calculation of disease intensity in population. The plant resistance score was observed based on the percentage of affected leaves using a 0 until 4 scoring system as shown before. Disease intensity in percent was calculated using the formula P or disease intensity equals to sigma n number of plants from each attack category times V, the scale value of each attack category, divide n number of sample plants times Z, the score of highest attack category, and it's all times the 100%. The intensity of disease in plants is also affected by time. The time in question is from the start of being attacked by pests and disease until it ends. The time includes start, interval, and finish.
Next analysis AUDPC area under disease progress curve. AUDPC area under disease progress curve is the level of disease incident in the treatment from the first week observation to the last week of observation. AUDPC can be calculated by the formula stated by Van der Planck as follows. The formula you can see in the screen. Information. Y is disease incident percent, T is time or day. The known AUDPC values are then used to calculate the disease suppression index. Disease suppression index is a number that can express the level of control effectiveness. A number that can express the level effectiveness of controlling a biocontrol agent against pathogens. Disease suppression index can be calculated by the formula indeks penekanan penyakit DAC minus DAB decided by DAC times 100%. Information: DAC is AUDPC on control, DAB is AUDPC on biocontrol against agent treatment.
Biocontrol agent used in this study were two biocontrol agents combined in various proportions. To determine the level of synergism between the two biocontrol agents, a Bot's formula is used. EX mean A plus B mean or A times B divide 100, and SF equals E ops divide EX. SF is synergy factor, A is control effectiveness by biocontrol agent 1, B is control effectiveness by biocontrol agent 2, EX is predictive control effectiveness by a mixture of biocontrol agent, EOPS is control effectiveness by mixture based on observation. Relationship between the two agent biocontrol is determined by if SF equals 1, interaction between biocontrol gain additive. If SF less than 1, the interaction between biocontrol gain is antagonistic. If SF more than 1, the interaction between biocontrol gain synergistic. I think that's all our presentation. Thanks for your attention. If you have any question, you can write it below. Wassalamualaikum warahmatullahi wabarakatuh.